look at the practical application of SPSS in conducting the independent sample test. So if you have a look at the data, at least for firm size, we have two types of sizes. Is that not it? Let me check and see.
The firm size 3 or?
It's 3, right?
So I think 6 is there.
Okay, so we have 6. So the sex is what?
So we have
male and female. Okay, that is the grouping variable, and it must have at least what 30 cases. So you have to first of all run descriptive analysis to check the frequency. Do you get it?
Okay.
You see, if each of them is up to the minimum of 30 cases, and when we run this one, we can clearly see that the male are 181 and while the female are 67. So we can compare their voices. Is that not it? Because they all meet the minimum of 30 cases. Yeah, that is what it means.
Okay, so they shouldn't be the same.
You can make them the same, but
And
the
the minimum
you can also
yes.
like they can be. This so far as they are 30 and more is allowed for you to compare.
What I'm saying, that one can be more than the other.
Yes, yes. Okay. But there are circumstances that will tell you as to when you want them to be more than the other. It could be proportional. Average figures may be different, but they are in percentage wise, they are proportional to each group.
I think before they are dealing with these after, but they will be the same. They're people so.
Yeah. So, what is the procedure? What do you do first? So let's look at the dependent variable that you want to compare. As usual, let's use the financial performance, which indicator you want us to use? The profit, right?
FP is profit.
FP6, profitability.
So whatever, if we decide to use what we last the calculated, the new lesson, so like if you know we'll have added from, can it be used that one to calculate?
Yeah, imagine that we have done the transformation for all of these things, then we can use them.
Okay.
But that one, I just, for purpose of instructions,
okay.
we just transform only one for you to know that if you have that cases, you have to transform all of them before we come and form one constant. Okay, so let's quickly do the selections and then see how it goes. So you go to analyze, and then the next place we go to is what? Compare what means. And go to where? Independent sample t-test. Okay. So you can right click to display the variable names as we always do. So what is the dependent variable?
Select F6.
Yeah, FP6. You select that one and move it to the test variable. Okay. Then you come and select the grouping variable, which is the 6, right? And put it in the grouping variable box. Have you seen it?
Yeah.
Put it in the grouping variable box. Then after that, it will ask you to define groups. How did we code this thing? You say 1 is for what? You can check it from here. Have you seen it? 1 is for what?
You can check it from
the volumes. The volumes for jet. The 6 when we're doing the coding. Come to the value, click. 1 is for what?
1 for male.
2 is for what?
2 for female.
Good. So they said it is asking us to define the group. Click on that. So group 1 is what? Male. So you put 1 there. Group 2 is what? Female. So you put 2 there. Have you seen? Then go to continue. What else do we have to do? Is that not? That's all.
No, let me see.
The value for this bill cannot be okay. Yeah, that's it.
So click OK.
182.
Yeah, click OK. So this is the independent samples t-test results. Let's quickly go to the ones that we are interested in. Now the results has come, so we are interested in group statistics table first. Okay. So look at the group statistics and let's look at some descriptives about them. How many of them were male?
181.
And how many were female?
60,000.
Okay. What male what is the mean score profitability for male and also male for female?
For the male is 3.597.
And for female?
It's 3.7313.
Okay, so which of them is per this absolute figures? Which of them are making more profit? The businesses that are managed by what? Female. Okay. That is what the data is saying. Now we have to come and check whether this difference is significant or not what? Significant. That's all. So now let's go and copy the other table and bring it here, which is the independent sample test. So this is our result. Okay. So independent sample test, there are three things that you have to consider here. Okay. The first one I want you to consider is what we call living test for equality of variance. This one is an assumption. You have to check first. And we use the first sig value for the F statistics. Have you seen sig here? It is this sig that we use to check whether that assumption has been validated or has not been violated. Then we also have the second thing you have to consider is whether you have to use the results labeled equivariances assumed or equivariances not what. Have you seen that there too? Okay. So the thing is that if you violate the Levin's test for equality of variances, then you use the equivariances what? Assumed. Sorry, equivariant not what? Assumed. If you violate it, then you use the equivariances not what? Assumed. I mean you use the sig value here. Have you seen the second sig? To check whether it is significant or not what? Significant, that's all. But if you don't violate it, you use the significant here at what? The equivariance is what? Assumed. Okay. Now let's look at how to test for the Levin's test for equality of variances. This sig value, this assumption is saying that it should be more than the 5%, okay? If it is more than 5%, then equivariances assumed results will be used. But if it is 5% or less, then equivariance is not what? Assumed.
So report on the down one.
Yeah. So if you look at these results, we got 0.0, 0.00 the sig value, right?
Yeah.
Which is less than what?
0.05.
So which results are you going to use?
Equivariance is not assumed.
Equivariance is what? Not assumed. It's because this assumption has been what? Violated. That's why we are using equivariance is not what? Assumed. Okay. So once we are using the equivariance assumed, you now come and check the sig value for here. Is it significant or not significant?
Significant.
If it is significant, what do you conclude about the findings?
Our finding is not by chance.
It's not by chance. So we can say that female managers are making more profit than what? Male managers in the poultry industry. That's all.
Because the other statistics too.
Yeah. You know, first of all, we examine this and establish that the females are doing better than what? The males. They are doing better in what? Look at what? What are they doing better in?
They're doing profit.
Very good. They are doing better in what? Profitability. So we can emphatically say that per this data, businesses being managed by the females are making more profit than what? The males. So what advice will you give to the employers?
And we are going to employ more females.
Oh!
And you should motivate those people that are already working.
Yeah, so to maintain them so that they don't go.
They don't go away.
That's all. Can you interpret it now?
Now, whenever I now take it to my area, you know that you use only business. When you are now sit and take it to my education.
Hey, GS. Let me keep quiet too.
So yours can be just encouraging maybe girls in school.
Yeah, encourage females.
If it is about teaching practices, maybe female teachers do well.
Yeah, teaching practice and
Teachers. So we should try and pull them more.
yeah, those kind of comparative analysis they work in your area.
Yeah, that so I always translate it.
Yeah, in the business field.
Yeah.
So when you validate the assumptions underlying the independent sample test, like maybe you didn't use probability sampling in selecting the respondents,
Okay.
or the dependent variable is not normally distributed, and other major serious violations are there, then you have to go and use the non-parametric alternative. And then the non-parametric alternative for it is the man-Whitney. That is it. This is the one I'm talking about. The man-Whitney U test. Okay. Let's look at the procedure and use it. So we are doing that. The data set that we are using, we have validated that assumptions. Okay. So let's use the man-Whitney test to also compare the performance of the groups. So again, each group should be at least 2 cases. Okay. So the group should be at least 2 cases, and then also the dependent variable should also be continuously measured. Except that when you validate a lot of the assumptions, then you have to come and use the non-parametric alternative. So let's use the same variables and also see how we can compute it. So the first step is what? This is the procedure. So it says that we should go to analyze.
Click on non-parametric test.
Analyze non-parametric. And go to what?
Then you go to independent samples.
Yeah. My own, the legacy will dialog will open so that we can have more. Okay.
So we should rather go to the legacy diagram.
Yeah. It will open the other options for you. So we have 2 independent samples. Is that not it?
Yeah.
Okay. Click on that. Then what did they say?
Then after that, click on continuous dependent variable.
So which is FP6. And put it in the test variable, right?
Yes, please.
Okay. Then what else?
Then you click on the categorical independent variable. And
Okay.
you see the grouping variable.
Okay. So which one are we using?
You can still use set. So
Okay, look. Okay, put it there. And what else?
after that, you click on define groups. To
So
define
we have to define, come and define the groups.
So that will be one.
We have group 1 and group what? 2.
Why is my defined group not activated?
Have you selected the sex grades?
Yes.
If you select it, it will be activated. Okay, and the test type, are you done with it?
Then after that, then you click continue.
Okay. But make sure that when you see test type,
Then
mine
make
is
sure that the
selected.
line box at where? Okay, yes.
Okay, right. So this is the results of the man-Whitney test. So let me clean this and then paste it there. So, as usual, you go through your descriptive statistics. Okay. What is how many of them were male?
101.
And the female?
67.
Mean rank.
Is that?
Mean rank. Which of them has the highest rank?
That is
Female.
male. That.
Female have 142.48.
Okay. So if you look at their mean rank, you can say that the females are doing better than what? The male. So what we have to look out for is to check whether it's significant or not. We come to what we call what? Asymptotic significance. Have you seen this one? Asymptotic. So, as usual, the rule is that if it is less than 0.05 or equal to 0.05, the conclusion is that it is statistical what? Significant. So, from this, what can you say? So, we conclude that female businesses are doing well in profitability than what? Male businesses. The same thing has come. Look at the result that we got for the estimate. They didn't even use the mean statistics. So that is it.